Okay, so 6.1, we are determining whether an ordered pair is a solution, and we are graphing using a table. So we are doing two things here. The very first thing we have to do is label the parts of the graph. See those two long lines that make a cross across the graph? Those are the x and y axis. Does anybody remember which one is the x-axis? Christina. The horizontal, side to side. Okay, so that one is the horizontal, is your x-axis. So let's label that. Okay. So your x-coordinate comes from the x-axis, which makes the other one which axis? The y-axis. Okay, so I want you to label those, x-axis and y-axis. The entire graph is called a coordinate plane. So if I ever tell you to draw your coordinate plane, it means the x and y axis. Okay? So the whole thing is called the coordinate plane. You have an x-axis and you have a y-axis. Okay, so also on our graph are going to be what we call ordered pairs. I'll give you the definition of an ordered pair. It's right down below. An ordered pair is a point on the graph that has coordinates x and y. We write it in parentheses. The parentheses are very important, as x, comma, y. Okay. So we write it as x, comma, y. It must be in parentheses. That is the most important thing. So if I wanted to actually graph some points, let's see. I'm going to do, everybody plot a couple points with me. I'm going to go right 3 spaces and up 2 spaces. So put a point, right 3, up 2. Can everybody see that point okay? I can do it a little bit bigger. Right 3, up 2. Okay, so how do I actually write that coordinate? Do you guys remember from graphing before, do I count left and right first or up and down first? Left and right first. If I'm going to the right, my number is going to be positive or negative? Positive. So if I wanted to write that point, put it in a parentheses. I went right 3 spaces, so that's going to be positive 3, comma. I went up 2, so that's going to be positive 2. So that point, the coordinate is 3, 2. Let me give you another one. For the second one, I want you to go left 5 spaces and up 6. So left 5, up 6. Plot that point, and I want you right now to write down the coordinate for it. Okay, Jasmine, so what are the coordinates of that one? -5, positive 6. Do you guys agree? I do. This should be review, right? Kind of. Do you want to do one more?
No.
Are you good? Okay, so you have your points labeled. You have the definition of an ordered pair. So let's actually look at what we do to graph these things. Okay, guys, so we're actually going to be graphing these things using a table. So that is your topic, graphing with the table. Step 1, you're going to plug in the x value to the given equation. So you can see the table right underneath. That's what it's going to look like. The first column is the x value. The second column is the actual equation. Third column is where we get the answer from, or where we put the answer. And then the last column is going to be the actual point. So step 1 is you're going to plug in the x value. Step 2, you are going to solve, and that will give you your y value. So now we have our x value and our y value. Then you will be able to plot your point. using the x comma y like we just practiced. So you're going to end up plotting usually 3 to 4 points. You are going to want to connect all points with a straight line. Okay, so for example 1, you have your x values in that far left column. 3x minus 4, that is the equation for the line. So what you're going to do is you're going to take the x value for each row and plug it in for the x value in the equation. So for the first one, we would actually write out that second box as 3 times x, but x is going to be what? Negative 2. So 3 times negative 2 minus 4. And then this is just an order of operations. What's 3 times negative 2? Negative 6. And negative 6 minus 4 gives me? 10. Negative 10. So your y is negative 10. So if I wanted to write that as a point, how would I write that as an ordered pair? Negative 2, negative 10. Okay, so let's actually graph that one right now. So negative 2 means I'm going to go, to the left 2 spaces and down 10 spaces. I don't think I have 10 spaces. 3, 4, 5, 6, 7, 8, 9. I have 9, so 10 would be 1 down here on mine. Okay, so just make sure that you give yourself 10 little marks, okay? So for mine, 10 goes off the graph. Okay, what I want you guys to do right now is finish filling out the chart. If you need help, ask your neighbor. Okay, Chi. Why don't you write it for us?
Oh.
Just be careful about your hand. So that's going to be 3 times. It's okay. Okay, so 3 times negative 4 times negative 1 minus 1, what's that give you? What'd you get for the next column?
Negative 3.
Negative 3? No.
Oh, wait. No. Negative 7.
Okay, so write in negative 7. And then give me write out the point for me.
On the x, y?
Mm-hmm. Good. You guys agree? Yes. Thank you. So where would I plot that? I would go left 1, right? And down 7. So that would be right here. Okay, good. All right, next one. Let's see. Okay, Angel, next one for us, please. Fill out the next line of the chart.
Weird. Hard to write with.
So he plugged in 0. He got 3 times 0 minus 4 equals negative 4. So his point comes out to 0.
Yeah, and kind of.
Negative 4. Do you guys agree? Yes, the only thing, Angel, that I would correct is make sure that you finish the parentheses, okay? Okay, you guys agree with 0, negative 4?
Yes.
Yes, all right, good. So that one would be graphed, thank you, to 0, 1, 2, 3, 1, 2, 3, 4. Here. What do you guys notice about the lines?
What?
What?
X and y is kind of at negative 10 plus 3 equals negative 7.
Uh-huh, we're adding 3 each time. What else about the positioning of the dots?
Oh, they're making a line.
They're starting to make a line. Do you think it's supposed to be that way?
Yeah.
It is. So I'm going to do the last line of the chart for us. That's 3 times 1 minus 4. 3 times 1 gives us what? Negative 3 times 1? 3. And what 3 minus 4 gives us? Negative 1. So our last point is, 1, negative 1. So when we plot that, it should look like this. And they're all making a line, right? It's supposed to make a line. So it should, if you're graphing correctly and if you're doing all of your work correctly, it should make a line. So the last step is to draw a line through all of those. What's the one thing we have to make sure we put with lines? Arrows. Why?
Because they never stop.
Lines never stop. They go on forever. So you connect them all with a line with arrows at the end. Okay? All right, so I'm skipping example 2 because it's exactly the same as example 1. The only thing that was different about example 2 was that we were multiplying by 1/2. But you guys are experts at that, right? Yeah. Multiplying by 1/2 is the same as dividing by 2. Do we have to write the steps? Yes, you do need to write the steps. So what we're going to be doing now is we need to determine if a point is a solution. What's another word for solution, guys? Answer. So solution or answer, same thing. Okay? So first step, you are going to plug in the x-coordinate for x and the y-coordinate for y. So you can see example 3 down below. I will give you a point and I will give you an equation. You have to plug in x for x and y for y and then simplify. So step 2 is to simplify that. So after you plug everything in, you're going to simplify. When we simplify, we are going to be looking for true or false statements. If the statement is true, that's actually what we want. The point is a solution. If it is not true, it is not a solution. I'll show you. Okay, so one notation for you guys is that remember how we were just graphing points on the line? If you get a true statement, which I will show you what a true statement looks like, the statement is a solution, or the point is a solution, but it is also a point on the line. Okay, so solutions are also points on the line. So if I ever asked you to graph it, you would use that point to graph. All right, guys, so example 3. I want you to determine whether the given point, 3, 7, is a solution to the equation y equals 3x minus 2. First of all, we need to figure out which one is the x-coordinate and which one is the y-coordinate. Of the point 3, 7, which one is x? 3. So right now, just for the sake of the first example, I want you to label it. Okay, so which one is the y-coordinate? 7. Okay, so now what we're going to do is step 1, we're going to plug in the x-coordinate for x and the y-coordinate for y. So the equation is y equals 3x minus 2. What am I plugging in for y? 7. So this is going to be 7 equals 3 times x. X is 3 minus 2.
Wait, is that how we figure out if it's a solution?
Mm-hmm. Okay, now it's just order of operations. So we have 7 equals, what's 3 times 3? 9 minus 2. And what's 9 minus 2? 7. So I get 7 equals 7. Is that a true statement? Yes. So that's what a true statement looks like. Okay? So you have to get the same number on each side.
So if it's 6, it's not a solution?
Correct. So if we were to get 7 equals 6, not a solution. But 7 equals 7. So what we would say is that the point 3, 7, yes, it is a solution. Make sense?
Yes.
Okay. So example 4, does the point 4, negative 5 lie on the line represented by the equation 6x minus y equals 10? Do it on your own. Okay, guys, so everybody take a look. All right, first of all, in this problem, which one is the x-coordinate? 4. Which one is the y? Negative 5. Now, what did I always tell you should do when you're plugging something in? Put what around it? Parentheses. So, this is going to be 6 times 4 minus y. What's y? Negative 5. So, that's going to be minus negative 5. Oh. Equals 10. Okay, so what is 6 times 4, guys? 24. Minus negative 5 turns into positive 5. And 24 plus 5 gives me 29. So I get 29 equals 10. Is that true or false? That's totally false. 29 does not equal 10. So is the point a solution? No. Okay? That is 6.1. So 6.1, we were graphing using a chart. You plug in x and solve. And we also determined if a point was on the line or if it was a solution. It means the same thing. So you plug in x and y, look for a true statement. All right?